and welcome to today's program on the Thirsty Triangle, the water footprint of energy trade between China, Canada, and the United States. I was just talking with Jennifer Turner, my colleague from the China Environment Forum. This is about our 7th co-production. We've sort of done an annual co-production on China, Canada, the United States, or China, North America.
And next year it'll be the 8th one, which will be the extra lucky one. So yeah.
Absolutely. We want to be auspicious, right?
We burnt lots of incense at that one.
So the Canada Institute looks at energy, environment, trade, and border security, and this falls nicely into our energy and environment lane. And it's our pleasure to be working with you today. I'm just going to introduce Jennifer as my colleague. Say the exits are out here. We are being webcast, so please, when the question comes to you, wait for the microphone. And I can't think of anything more, Jennifer, so.
They should refrain from doing the wave because it gets in the way of the camera.
Yeah, that too. So, okay, Jennifer?
Okay. Hey, good morning, everyone. Kudos, you guys all came on time. A few other people coming in, we won't look down at them. But yeah, so let you know, as Dave mentioned, I direct the China Environment Forum, and here at the Wilson Center, I have to be proud that we were the ones that really started the whole idea of the water energy nexus work here at the Wilson Center. 3 years ago, we began a partnership with Circle of Blue, an NGO based in Michigan that do these fabulous multimedia reports on freshwater crisis issues, well, not just crisis, freshwater issues around the world. And we've done 2 field trips to China looking at how energy development is impacting water. And I hope you go to the website and see the reports, but what's exciting, and some of you may not know, is that in another couple weeks, we're going to have Choke Point India stories coming out. The president of the Wilson Center, Jane Harman, really likes this Choke Point stuff and has given, and I get to put a new title on my card. I'm going to be, you ready for this? The Global Choke Point Initiative Manager, or just Global Choke Point Manager, so it's kind of like taking over the world. And so I'll be working, over the next few years, I'll be doing more work with other projects at the center, looking at how the energy, water, and often energy, water, food nexus or confrontations, interactions in different countries. And we've kind of been doing this for a while. We were like soft launch of Global Choke Point for many years here. And if you didn't grab it, we do have a little outline of our Global Choke Point initiative out front and why you should care. But I think you guys do care because you came to our meeting today, right? You were interested in Canada, China, and the United States. And got 3 speakers here. Different guys, and we've made a vow I'm not gonna read you the bios, okay? But I do want to point out that we do have a civil engineer, an economist, and a physical geographer. And from their 3 different fields in the course of their careers, they have come to the water energy nexus. And between the 3 of them, they're gonna be talking about some of the water energy confrontations within North America and China. And Steve, the economist, is gonna do a little bit more of the heavy lifting on the water that's embedded in energy and also other kind of trade out of Canada. So hopefully you're going to walk out here with not a headache, but a full brain of lots of information. And again, no bios, you've got them, but they are incredibly smart and nice guys. Speaking of which, we'll start with the first. Very smart and friendly, nice guy. Mike Hightower, he is from Sandia National Lab. I can say that at least, right? All right, go for it. You can start. And he wants the mic.
All right, let's see. We're going to try to do these in 20-minute segments so that there'll be plenty of times for questions and answers. So what I think, if there's any questions on a slide, if it's to try to explain the slide, we probably ought to take that question, but then we'll hold the questions for later. I've given a couple of presentations on energy and water at the Woodrow Wilson Center. This is the 3rd. I changed this up just a little bit to talk about natural resource issues, not only water, but greenhouse gas issues, because I think all of these things kind of will begin to play in the future as we look at water, embedded water, sustainability long term. So a lot of people, I think, will wonder, why in the heck is a national laboratory interested in energy and water issues? No. Sandia is a national security laboratory. We do a lot of weapons work for the U.S. government, for the Department of Energy. And in my former life, when I did weapons work, water infrastructure, energy infrastructure, we didn't call them infrastructures, we called them targets. And I think that the point is that infrastructures, critical infrastructures, are very important to the economic, social well-being of countries and regions. And if you look at Hurricane Sandy that hit New York and New Jersey, the fact that a natural disaster can take out transportation infrastructure, energy infrastructure, communications infrastructure, and the kind of issues and problems associated with that, that these infrastructures are important. They're national security issues, they're economic development issues. And so I think that what we need to look at is these infrastructures in a little bit different context, within a systems context. And so when we look at energy development, I think the discussions in the last 10, 15 years on energy development have been on one, security, two, greenhouse gas emissions. And I think that that's very narrow. So I think as we begin to open that up, that we will see other things that are impacting energy development, the economics of trade, and water is going to be one of those. So I'm going to talk about natural resource issues in general, interdependencies and systems level thinking, because I think it's important when we have a global economy, global energy development, global demands, how those all factor in. So let me just put this quickly in my vision of what are energy's impact on natural resources, and the fact that we don't really discuss that within a systems context. What I show here, we got a cold guy here that's going to take issues with this slide, but and even Public Service Company in New Mexico, when friends of mine see this slide, they come, Mike, we're going to kill you. But this is a cartoon a few years ago out of the paper talking about zero emission electric vehicle. So if we talk about just the tailpipe of a car, and that's all the system that we're looking at, we can forget some of the other things that go into making that car run. So my point is, this is a good example of what I call too narrow a thinking, and we need to look at the system more appropriately. I've got, just not to pick on the coal industry, I've got a hydrogen car or hydrogen fuel cell example, and this is a little more, maybe not as intuitive, but I don't know that people understand that one of the major ways to get hydrogen is steam reforming a natural gas. So CH4 is natural gas. You add water and heat, energy, to come up with hydrogen for the fuel cell and CO2. So my point here is this zero emission fuel cell, one, uses fossil fuels, two, uses a lot of energy, uses a lot of water, creates a lot of CO2. So it in itself is not, pollution free. It has issues associated with that. My comment is we need to look at our energy systems on a much broader perspective and try not to pigeonhole some of the discussions. So my role today is an enlightener. Civil engineers are not necessarily really good at enlightening people, but I'm going to try today. Economists aren't either, so.
Yeah, but
See how it
Steve
goes.
says he's good at jokes. So.
I've heard his economist. You tell him your economist joke here in a minute, and let's see how many people laugh at that. All right, so here's the issue I think with the energy systems as we look at new technologies, new approaches. They are very natural resource dependent and resource dependent. So not only do we have to talk about water, air sheds, greenhouse gas emissions, air pollution, but you need to talk about where the fuel comes from, what kind of fuel, that is a natural resource, the land use, the land associated with that. Large renewable energy projects take a lot of land. There are ecological issues in developing some of these renewable resources. Water is used in almost every energy development. And it, depending upon what type of energy system you use, it can be a very large percentage of the water use in some of those regions. And then, of course, the other resource is capital. We can have a lot of interest in doing altruistic activities, but it all comes down to cost benefit. We don't have an infinite supply of capital. The interdependencies, the reason that we really need to look at this from a systems level perspective, not only on the natural resources side, but the fact is all of our infrastructures are becoming more and more complicated. You have to have transmission for electric power. You have to have transmission for natural gas and fuel pipelines. You have to have a fuel resource and the transportation to get it to where you need it. You've got water. Now with the advent of computer systems, telecommunications to allow you to do automatic switching and changing, you've got to have that infrastructure has to be included. Cybersecurity is a big issue as we move forward on these infrastructures, especially infrastructures like energy that are distributed. Gas pipelines, transmission lines are going through thousands of miles, hundreds of miles of uninhabited territory, at least in New Mexico they are, in the west and in northern Canada. You can't protect these infrastructures the way that we have tried to protect them in the past. So it's a different paradigm and a different way to think about how we look at the system and getting a high performance system. The other thing that we want to look at, and I go back to my early days at Sandia when I worked on weapons and looked at targeting, you know, you're always looking for that single point of failure. Is there some place in that system that if I attack it here, it takes out 5 or 6 or 7 infrastructures? I think what we'll probably talk about today is that water is becoming maybe the Achilles heel of some of these energy development in a number of areas, and it's something that needs to be looked at. Have you ever been to a presentation where a CEO of a company gets up and then the first slide they give is a slide that's full of 2-point font stuff about disclaimers, and so this is kind of my disclaimer and but also my direction of where I'm going to go today with my presentation. These issues have been around for a while. I work with the National Laboratory team that's been working on energy and water interdependencies since about 2002. There's a number of reports from all the national labs, Sandia, Los Alamos, Argonne, Brookhaven, and others, Oak Ridge, NREL, National Renewable Energy Lab, about some of the issues around energy and water. So there's a lot of information and references, but I think what we're seeing within our National Lab working group is that the water footprint, like the carbon footprint, is going to be what we start to look at when we look at energy development, sustainable development. And there's a report there that I have on ASME magazine, Mechanical Engineering magazine, that you could look at that kind of gives an overview. The other thing that I have there is at the bottom is that this whole concept of integrated resources management principles. I think the systems level thinking, systems level context is what we're going to have to do as we move forward when we look at energy development, look at the natural resource impacts, just not CO2. And the second one, in the middle one there is a quote from one of our senior scientists who's worked on climate change issues for the last 25 years. And his point is, and I think this is kind of the wild card in all the discussions, is climate change. What's climate change going to do? How's that going to impact energy development? How's it going to impact natural resources? And I'm going to show that what Bernie has mentioned here is that water and watersheds is where the climate change rubber meets the road. That's his quote. That is where we're going to see climate change really having impact on water resources, land, evapotranspiration, and the fact that in some basins we're going to see 50% less water supply in the next 30 to 40 years than we have today. So how are we going to do agriculture? How are we going to do municipal supplies and energy development when we're looking at a lot of regions of the world that will be having to deal with 50% less water supply? So that's kind of my disclaimer. It's also kind of where I'm going to go with my presentation. I'm going to talk about the water issues today, what climate change is going to do to that, what some of the energy development projects and technologies, how they use water, the amount of water that they use, and maybe start a little bit systems level thinking for everybody. Didn't work. Okay, I'll focus my discussions today on North America. So I'm going to have a little bit about the United States, Canada, and a little bit about Mexico. But I just wanted to put in perspective the current situation in the United States about water supplies, both surface water and groundwater. On the left-hand side, you see a surface water withdrawal capacity curve for the United States. it says that about 1980 we maxed out on surface water supply availability. We haven't built any new large dams. And with climate change, what we're seeing is that those dams are probably being overutilized, overappropriated for the water inflow. So what we're looking at in the next 40 years is actually a reduction in surface water supply capacity in the United States. So what we've been doing for the last 40 years or 35 years to kind of address the emerging demands, since we haven't really developed a lot of additional freshwater or surface water supplies, is we've moved to groundwater. And a lot of portions of the world have done the exact same thing, and I'll talk about that. And that is that we mine groundwater to a point where it's kind of unsustainable. And what I have on the bottom right is kind of a curve of those basins in the U.S. that are impacted by either overpumping or salinization, either through saltwater intrusion, or they're getting far enough down in the bottom of these aquifers that they're seeing salty water rather than fresh water. The point that I'm making is that everybody talks about the Ogallala aquifer here in the center part of the United States, but the point of this slide is to show you that it's just not the western U.S. that's having problems with water supplies. We're talking about parts of the southeast, the Midwest, places like Wisconsin and Minnesota. You know, who thinks of Minnesota is having a water problem? I don't think anybody in here does. But if you really look at the data, there are several regions of Minnesota that are having water issues. Now, you look at South Dakota and North Dakota, you can see that they've had some water issues there. That's some of the Bakken areas that people are talking about of fracturing. So there's going to be competing demands in those areas where there's already limited water supplies for that type of development. So just remember this curve for the United States. Some of the areas will extend up into Canada, and I'll talk about that here in a second. But currently, we're kind of over-allocated our surface water. We've over-allocated our groundwater. And yet, a lot of the technologies that we're talking about, biofuels, more water use intensive. Some of the power plant systems, EPA regulations are looking at more water use intensive for cooling. So we're going to have to look at that very closely, because from a system standpoint, that may not be appropriate to try and drive us to more water use intensive technologies. So the question is, really, if we have a water problem, does it really impact energy? The answer is yes. Over the last 5 years, this is just a sampling of places where permits have been denied for energy facilities. Some of these are power plants, some of them are biofuels facilities, some of them are solar power plants because of not enough availability of water. So you think about it, where's there a lot of solar? In the desert? What do you have in the desert? Well, you don't have any water. So some of these technologies, and I'll show you here in just a second, do require a significant amount of water for cooling. So we're already seeing and have seen in the last 5 to 6 years water limitations impacting energy development in the U.S. So I want to move a little bit to climate change. If you really look at the IPCC directions on climate change and what the impacts are going to be, everybody says, God, it's going to get hotter. That is the number one. I mean, they talk about that. But if you look at all the other things that are listed in the tables, droughts and floods, water. More frequent storms, water. Rising sea level, water. Snow cover shrinking, water. And if you go down here and look at then the impacts, this is from Jan Dell from CH2M Hill. People has done a lot of work with the World Business Council on sustainable development and tools to look at water impacts. But just look on resource production, transport, refining, pipelines, electric generation, transmission. There's water issues in all of those. So the energy sector is going to be impacted by climate change. Water will be one of those major impacts. And I'm bringing this up, and I'm kind of focusing on North America, but I'm going to mention some of the other regions of the world that are going to have the same kinds of problems. You look at the climate change issues. This is out of National Geographic, but it's out of the IPCC. Here's North America, Canada, the United States. These are reductions in precipitation, in percentages, 10, 15, 20% reductions. But you can see that these areas, North America is no different than Southern Europe, Northern Africa, India, China, or any different than Brazil, Argentina, Southern Africa, and Australia. So many of the developed countries and many of the developing countries that have large economies are going to be impacted by climate change similarly, which is 10 to 20, 25% reductions in precipitation, which directly translate into water supply availability, additional competition for water resources, and that means that energy's demand for water resources is going to be at direct conflict with water for domestic supplies, water for agricultural development and food. So, where are the climate change issues projected to be done? What do a lot of people classify as arid and semi-arid regions? Well, southwestern United States and parts of western Canada, parts of the Mideast, India, northern China, Australia, southern Africa, and the same regions. So the regions that are already dry are going to get drier based upon what we're seeing from the IPCC, which says that we get a lot of energy development in the western US and western Canada. That's going to be the place where we see significant impacts. We're seeing significant impacts in India, and we're seeing significant impacts on water supply availability in China. So this is real. This needs to be, this is not a US problem, this is a global problem. So if you take that map and you kind of show where the natural gas resources are, shale gases and tight oil, I mean, they almost match directly. We did a good job of putting all of the shale reserves in places that are deserts. So, so the point is, I brought this up to the front just to show that where we have these problems of water supply availability is exactly where we're looking at a lot of the energy resources. And you look at the major energy resources for gas, for example, in the world. You look at North America, Canada, US, and Mexico. You look at Argentina and China. Those are the areas where exactly where we're looking at a lot of water stress. So it is going to get probably more acute than it is today, and we need to start thinking about it in this global systems level perspective. Just wanted to mention some issues around water availability and climate change and watersheds. This is some data from the United States looking at forest fires. I've followed that for a long time. And in 2006, I got to be worried about this trend, and so I made a statement in one of my papers, you know, this is something that we have to look at. I predicted this trend in 2006 from the data, and everybody said, Mike, this is really not what's happening. So now I've plotted up for the last 7 years where the data really shows. And I'm off a little bit, but in reality, I'm not off that much, which suggests that things have started to get bad in 2000 decade. It's really going to get bad. And I think this is a trend we're seeing in all the watersheds in these climate-affected regions, is that we've got some exponential growth. We have to start addressing these issues today. Last thing I wanted to mention is that in November, both NOAA and U.S. Forest Service looked at this and said, you know, we're having a problem, and I'm glad that they agree with me now. But the point is that we're on an exponential growth here. We have to start talking about this now, and we have to start coming up with solutions now. It's not something we can put off for another 10 years. One thing I want to bring up real quickly, I'm almost done, is that the direction for the growth in U.S. gas production, and I think this is really for North America, is that if you look at the projections from the EIA, both for gas and for oil, it's really about fracking. Fracking of these tight oils, fracking of the tight gases. And the point I want to make is hydraulic fracking is the fracking system of choice today. We've got to be smart about that because we're using 3 to 5 million gallons of water per frac. And when we get finished with it, the water's coming back at anywhere from 100,000 to 200,000 parts per million TDS. Seawater is about 35,000. So we're talking about, these shales are very salty. They're from old days when they were sediments in oceans. And so they've got a lot of salt. We have to deal with the environmental impacts of that salt as well as the water demands for this type of fracking. So I wanted to point out here that as we move to natural gas, and that's the projection, there's a lot of benefits to that. One of them is greenhouse gas emissions. And we can see here that from annual energy outlook for the United States done by the EIA, we're looking at 10–15% reductions in air emissions because of movement toward natural gas. That's good. We also have to look at what do we do about water availability. And this is one of the slides that mentions that. If we want to really focus on air pollutants and greenhouse gas issues, we'll go to 3 technologies. One will be concentrating solar, one will be nuclear, and the other will be carbon capture sequestration. So if that's our focus, we better look at the system because those 3 technologies are the highest water use intensive and water consumption technologies that we have. Nuclear, and I have this in liters per megawatt hour. I did this for the Canadians, and I found out they don't use liters, they use gallons too. So, but for the rest of the world, I left it because this is so just divide by 4, and I'll do that in my head. Nuclear power is like twice what coal is as far as water consumption. Concentrating solar is essentially twice what you have for typical coal plants. And if we do carbon capture sequestration for a coal plant, we're almost doubling the water demand. So those 3 technologies really they address the air emissions issue, but they don't address the water issue. I think what you're going to see, from both an economic and a systems level perspective, is a lot of people will go with natural gas combined cycles combined with wind and solar. Why? Both of those have lower emissions, and the water consumption is about half of what it is for a coal plant. Of course, these are almost 0. So if anybody wants to know what a projection or a prediction 10 years from now, 15 years from now, there's a reason I put them in green. Those are what I'm going to call green technologies. They're really turquoise. They're a combination of water savings and air emissions issues. So wind, I think you're going to see wind, solar, photovoltaic tied with natural gas combined cycle.
And we did post these online in PDFs.
Okay, all right.
Because of his itty print.
Real quickly, let me talk about biofuels because that's an important issue. We look at Canadian oil sands. They call them oil sands. I guess in the United States we call them tar sands, but I think if you've ever seen them, they are oil sands. But conventional oil and gas, and I think you're going to see why conventional oil and gas still stays a big player in the next 20 years. 1 gallon, 1.5 gallons of water per gallon of fuel. If you look at anything else on this chart, biofuels, corn ethanol, lignocellulosic ethanol, oil sands, oil to shales, hydrogen reforming, it's anywhere from 5 to 7 times more water use intensive. If you go to irrigated agriculture for biofuels, it can be anywhere from 1,000 to 6,000 times more water use intensive. So I think what you're going to see as we kind of compete, do you want water for ag for food? You want water for ag for fuels. I think that this is going to be a big driver for why we continue to utilize tight oils, tight gases, gas to liquids, and the oil sands out of Canada. Because I don't think the water availability from a sustainability standpoint for some of the biofuels is really going to work that well. So this is my last slide. I just give you a point. Down here in the bottom right-hand corner, imported energy is imported water. I think a lot of people are going to get a hold of that. if I can buy buy oil from Canada, I'm buying water from Canada. If Canada exports oil to the United States, Canada is exporting water to the United States. So these energy technologies require a lot of water. And so when you're exporting the product, you're exporting that water supply for it too. The point I wanted to make is, and you can't really see it very well, this is for liquid fuels, this is traditional oil and gas. Then we have sugarcane, ethanol, and what we're really looking at is this energy return on investment. So if we have an energy return on investment that says it needs to be 5 to 9, here's corn ethanol. It's 1.4. That's probably not sustainable. It probably has a niche market, but it's not sustainable. So if you look at some of these other things like this has tar sands, so obviously it was done by an American. This should say oil sands. 5 to 1, and soy diesel is 5 to 1. If you try to trade those off, they're about the same from an energy return on investment. In reality, though, if we import this, we're using Canadian water. That may be good for us. So we need to look at that. That needs to be in the equation. That's all I'm saying. And if we look at some of these other technologies down here for electric power, on energy return on investment, there are a lot of things. Coal is pretty high. Wind is very high. But some of these other things, natural gas combined cycles, are pretty high on energy for return on investment. So we're going to have to balance that economics with the natural resources, both air pollution, water supplies, land. And that's my take-home message here is that water is a big issue in the United States and in many other parts of the world. Water availability is becoming more and more stressed. Under climate scenarios, it's going to be more so. And so when we look at energy development and energy exports, energy imports, we need to consider those natural resource impacts and water impacts as part of the equation. So with that, I'll turn it over to the next speaker.
As I change slides, you could tell your joke. You have a joke, right?
I'm gonna
see if anybody laughs at it.
I'm not going to tell my joke. I'll get in trouble a different way.
Okay.
The clicker.
Thank you. Let me begin by thanking the organizers for inviting me to speak on this issue. And it's especially, I guess, appropriate to have a Canadian here, given that it's the bicentennial of the war that you guys forget and we remember. You got to give it to us. You know, it was the last one that we did really, really well in. And especially given that the Jays and the Maple Leafs aren't going anywhere, so I got to hold on to that one little thing.
Hey, Steve, could you just bring the mic up just a wee bit?
Will
Thank
do. I'm going to focus largely on Canada and the United States with some discussion of our exports and our relationships with China. I don't want to spend a lot of time talking because I think it'd be more valuable to have a discussion on these matters. So in case you're planning to fade in your attention level, I'm going to give you the results right off the bat. First of all, Canadian-American trade is one of the largest trading relationships on the planet. It's very high in terms of its dollar value. It's growing slowly. In contrast, our trading relationship with China is quite small, but it's growing quite rapidly. With respect to natural resource extraction, I'm going to show you some numbers that might be a little bit surprising insofar as they provide a bit of a contrast to some of the things that Mike was saying. In Canada, at least, natural resource extraction isn't one of the largest water users. It is regionally, certainly in the Athabasca, northern Alberta, it's the most significant water user. But I want to show you some numbers that we have that might be useful to frame the discussion. And we also have some forecasts that have been recently done that we'll be able to show you. And finally, the one issue that I want to put on the table that was Mike talked briefly about is the role of agriculture, but the role of agriculture in terms of water quality. Because I think in some ways, at least for Canada, it's more significant than necessarily the role of the natural resource extraction industries on a national scale. So what I'm going to do is quickly go through some export statistics some information about water use in Canada and the different sectors, and then conclude with some information about what the impacts are in water quality. So, exports to the United States, as I indicated, it's a very large trading relationship. We're currently, on the order of about $1/3 $1 trillion annually. It's one of the largest trading relationships on the planet. It's also forecasted to grow by not just the Canadians, but most forecasters at a reasonable clip. What's important is, for the first time, at least that I know of in perhaps the last 20 or 30 years, for the first time, fuels are #1 export of Canada to the United States. Because of the Auto Pact, for many, many years, it was cars, trucks, auto parts. And for the first time, we now have fuels as being the major export. And it appears that that's going to be a growing trend, that will, exports of natural resources will be a growing part of our exports to the United States. And so that's an important issue. With respect to China, we don't trade much with China. Canada was rather late to the table on this matter. You'll see the figures here are less than 1/10 of what our exports are to the United States. But because we're starting with small, that's the beauty of small numbers. You can get good rates of growth from them. And so they are forecast to be growing quite rapidly. And so when we talk about the impacts of Canada's natural resource and food exports to the rest of the world, with respect to the United States, we're talking about now. With respect to China, we're talking about decades from now in terms of their significance. What do we sell to China? Well, essentially, we're the hewers of wood and drawers of water. For the most part, it's not very much processed natural resources. And I apologize for this slide. I was lazy. I just stole it from Statistics Canada. But it's important because, so here's 2010 in our major, the top 10 exports. And you go down the list, and so we have coal, which doesn't have very much by way of water implications, except local drainage issues, and largely from closed mines, but not from operating mines. What's significant here is oil and gas is not here. In fact, we export more lobsters to China than we do oil and gas. That was my joke, and it worked.
Yay.
I would imagine crustaceans will be falling off the list fairly soon, or displaced. Not that Chinese demand for crustaceans is changing. I think our exports are. What's important from a Canadian point of view is how our trading partners are changing rapidly. The United States will, for the foreseeable future, obviously be our largest trading partner. We have all the reasons, the gravity models tell us we will trade with the United States. But what's important is our trading partners are changing and are expected to change fairly rapidly. The BRIC countries will become more important, at least some of them, especially China. We do actually use the metric system occasionally. And we went to the metric system about 30 odd years ago in order to boost our trade with the EU. It didn't work, unfortunately. But we are starting to see some benefits of increasing trade with the EU, although declining with one of our world trading partners, the United Kingdom. And so, let me not go there yet. So in terms of what Canada sells to the world, we are, despite our best efforts, still largely hewers of wood and drawers of water, with the exception of, in some senses, the distorted automobile trades that came out of the Auto Pact and then the two free trade deals. We sell mostly natural resources, and that's important to Canada. Now, water use. I apologize for the size of the slide, but there's a lot of important messages here. First of all, Canada is by per capita the largest water abuser in the world. It's a dubious distinction, but it's ours. Who uses water in Canada? Well, on your left, those are thermal power plants, so producing electricity. And so they dwarf everything else. Now, these are once-through technologies. They have almost no environmental impact unless you're a fish who happens to be, unfortunately, close to an intake, and then you're not a fish anymore. But for the most part, except for very small thermal changes, these don't have significant impacts. And so they're very low consumption rates. They're primarily on the Great Lakes system. But they do represent, because recycling apparently hasn't hit yet for energy production in Canada, to a lesser extent in the United States, very, very large water use. When we go down, municipalities are second. They're now second. Manufacturing water use has declined significantly. But what's important is, you can't read it, but that's oil and gas, way down there. Okay. Agriculture beats them by a factor of 3 or 4. And that's important for several reasons. You may not be able to see the colors, but the red bars on the top are consumption. And when we talk about local environmental impacts, water consumption is very important to distinguish between water intake. But oil and gas, at least historically, is very small on a national scale. Now, once again, regionally, for northern Alberta and the Athabasca system, it's the biggest water user in the region. But from a national point of view, it's not a significant player yet. And then just a graphic to indicate the same. And what's important here is, like the United States, we saw water use peaking in part because we essentially exported some of our heavy industry to other countries, and now we buy back our water through steel and other imports. But also we had significant changes in efficiencies that allowed us to do this. Just 2 slides, and this is an important issue. The next 2 slides are going to tell you how much water is needed to produce a dollar's worth of output in the oil and gas industry and in agriculture, historically. I have some data in a moment about forecasts. So this is what you call a water intensity figure. So it's water use relative to the value of output. And what's significant here, this is with agriculture, we've had fairly reasonable growth in terms of the value of output, but significant decreases in water use. And so the amount of water used per ton of tomatoes, per $1 million of canola, et cetera, has declined significantly in Canada. And this is largely a result of on-farm technological improvements. There have been literally hundreds of millions of dollars invested in improvements in agricultural technologies, the lining of canals, et cetera, et cetera. And so significant improvements in water use relative to output. The same story is true for oil and gas. And so here, again, we have massive increases in the value of our production, largely price-driven, but also quantity-driven. And we have almost flatlined in terms of water intake. And so we have declining water use per dollar of output. Now, in total, if you get enough output growth, you're going to have water intake growth too. But at least historically, we're seeing the sector has been successful in terms of its recirculation efforts and actually driven down the total amount of water used. And as a result, kept flat the total amount of water used, and as a result, decreased its water intensity figures. You'll notice the slides are getting finer and finer, and I'm just waiting to see how many people are going to lean forward once again. Fortunately, an agency up in Canada called the National Roundtable on the Environment and the Economy, which recently died but because of funding problems, they did a forecast. And you need to know where you're going. And so this is the first time there was ever a serious forecast of water use in Canada. And so I helped direct the project. And we found some surprising results. There was a lot of discussion over the last decade or so about rapid growth in water demands and what are we going to do about it and that type of thing. And when we actually sat down and the forecasters crunched the numbers, there were some surprising results. Let me just point out a couple of them. So the really big areas of growth in water demands are oil and gas. Between 2005 and 2030, so the near medium-term future, we're talking about almost 100% increase in intakes, and agriculture, a 50% increase in intakes. And so very large rates of growth, right? Significant increases. Well, what does this mean in terms of the totals? Very little, right? We're still talking about, in terms of the totals, we're still talking about oil and gas being on the order of nationally 1% of all of the water withdrawals in the natural resources sector. And agriculture is bigger. It's now going to be closing in on 10%. So rapid rates of growth are significant, but you have to keep the scales in mind too, to understand that regionally these are very important, but nationally they're relatively small amounts compared to some of the other sectors. I'll have to check. I'll get back to you on that. Certainly on the agricultural side, the consumption figures are dropping because of the increases in water use efficiencies. We're moving away from spray irrigation and that type of thing, and so you're rapidly decreasing the consumption. And so on the agricultural side, I'd be surprised if the consumption numbers weren't flattening out. For oil and gas, I'm not sure. I'll get back to you on that. A graphic just showing basically the same thing. Now, before I get to here, so let's suppose we are concerned about growth in water use in the agricultural and natural resource sectors, either because they're regionally important, such as the upper Athabasca, or because they're nationally important. Agriculture is often competing with, in Canada at least, cities. Whether it's in southwestern Ontario, or southern British Columbia, or southern BC, there are already significant degrees of competition. The Bow River and the South Saskatchewan are over-apportioned. We get to join the club now, apparently. And so what can you do about it? Well, I betray my disciplinary bias. I'm an economist. I just, okay, a bad economics joke. We get a parrot, train them to say price, price, price. They're an economist. And so parrots are cute, though. And so suppose the one story behind all these water use figures is that almost all of the major water users in Canada get their water for free. Let me repeat that. So water allocations are a provincial matter with some small exceptions in Canada. And most provinces issue water use permits with perhaps an administration fee, but no subsequent user charges, if you like. British Columbia is an exception. One or two of the smaller provinces are exceptions as well. British Columbia earns somewhere on the order $300, $400 million a year from its water royalties, and those are under review. But for the most part, major water users stick a pipe in a river, a lake, an aquifer, and they draw it for free. And so naturally you might say, well, how about we just raise the price a little bit? Could that encourage innovation, technological improvement, conservation? In order to know that, you first need to know how much their water costs. And so these numbers are small both physically and also they're small economically. So yes, that's right. These are cents per cubic meter. Okay, so the cent you all know, because the Canadian dollar is almost equal to an American dollar these days. We used to be above, but At cubic meters, 250 US gallons, 275 US gallons. And so what does it cost to use a cubic meter of water in these industries? The highest one is manufacturing because of its treatment needs, and that's 14 cents a cubic meter. Okay, so I know mentally you're just moving the decimal place trying to figure out what that is a gallon, and it's just so small. If you're a clever engineer straight out of grad school and you go to your factory, you're working in a big scale factory, and you say, boss, I can save you lots of money, save you lots of water use. That's a really good way to kill your career. Tell your boss how she's going to save money in labor or energy or anything else, you might get a listen. Not in Canada on water. Water costs are so ridiculously small. And so oil and gas, because of recent, and that 6.6 is almost entirely on the tailing end, the discharge end. That's where they're spending their money on treatment. And so what happens if we start playing with these prices? What happens if we introduce a user fee of some sort, however defined? And so this particular report did an interesting thing where it asked, let's calculate backwards. Economists are good at working backwards. It's like, after 2008, we all started running backwards. Well, define the price that would get you a 20% reduction in intake. And then go to those bad guys called the macroeconomists and say, what would this do on sectoral output? Basically, how much of a hit is this sector going to have to take in order to get us 20% less water use? Okay? And here are the results. And again, I apologize for the size. I'll just tell you, that's 1%, minus 1% in sectoral output. Okay? And that's paper, because paper plants are quite old, they're inefficient. You'd really have to retrofit a lot. You'd have to actually close a few to get to the 20% cut. Nobody else is anywhere close. Let me see where I can get. Oil and gas there's tight natural gas and there's oil. So we're talking somewhere on the order of 1/10 of 1%. Okay, so 1/10 of 1% of lost value in order to get a 20% decrease in water intake over the next 25 years or so, 20 years. Is that worth it? Well, again, let's do a cost benefit, let's have a good discussion, but it's well within the range of feasibility, well within the range of we can accommodate it. It's not the type of thing that we're going to be shutting down major projects. So it is feasible physically, technologically, we know how to do it, and economically it's not going to have a very big impact if this is what we want to achieve. The last thing I want to talk about is water quality. Canada, you may think of as, I know Minnesota and Wisconsin like to think of themselves as the states of lakes. Well, Canada is the place if you want good, clean water, at least we used to be that way. This is a map showing basically fresh water quality. And the darker the dot, the worse the situation. And again, it's small, but what's important is the dots are not up north, with the exception of a few old mines. The dots are down south. And it's because people are dirty too. And especially our old sewage plants are particularly dirty. And so where we are running into the really serious water quality issues are either in agricultural areas in the southern provinces, where we have massive, for example, feedlots, or along the St. Lawrence, or a couple of isolated spots in Atlantic Canada. And so once again, freshwater by category, and this is now trying to categorize the land use around the rivers or lakes and trying to correlate the land use to water quality. And so what we see is agriculture is one of the big bad boys, especially in terms of the poor water quality ranking, this brick-colored bar. It's a significant causer of low quality water. And this is one of the things, the take-home messages that I want to leave you with, that in terms of, you know, Mike talked about when you buy our oil, you buy our water. Well, the thing that gets left home is the pollution. And unfortunately, we can't send that out too. And so we get left with the runoff, whether it be fertilizer, phosphorus, nitrogen, animal wastes, et cetera, et cetera. And this is a growing and significant problem. Once again, mixed pressures are essentially urban areas. And there we're talking storm runoff, leaky sewer systems, et cetera, et cetera. Mining, these are largely legacy issues. And remote, again. The other interesting thing about this that we haven't talked about is the potential correlation between air pollution from natural resource extraction and refining and water pollution. Right? A significant amount of water pollution in Canada comes from the air, simply because the rivers and lakes of Canada are big enough that they create a large enough surface area that airborne deposition of especially heavy metals and that type of thing are a really significant problem. Coal, for example, burning coal leads to, for example, mercury. And right now, the largest source of mercury deposition in our fresh waters is from coal burning. We're doing well in some respects. This is paragraphs that show the trends with respect to land quality and water quality in agricultural intensive areas. Land quality is improving, so in terms of topsoil retention and that type of thing. But water quality is not moving in the right direction. Our water quality indicators in our agriculturally intensive areas are declining. And so this is a real regulatory challenge. For those of you who have thought about agricultural non-source pollution, it's a devil to regulate. It's really a difficult thing. There's so many factors influencing off-field depositions. You can have the cleverest farmers in the world doing the best geospatial coordinated loadings, and you get one good rain and it all goes into the rivers. So it's a real challenge. And I'll leave you, I have some conclusions, but this is the western end of Lake Erie. It's the poor cousin of the Great Lakes. It's the shallowest and smallest of the Great Lakes. And last summer, the western third of the lake was the kind of place where you told your kids, don't you dare go near that. And really, don't go near that, because it's not that you fall in and get a bad cough. This is you fall in and, you know, that's the kind of stuff that your dog dies in. That's a very bad algal bloom. And for those of you who know Canada's water systems at all, there's a bigger lake called Lake Winnipeg, where it's about 3 times worse than this. Lake Winnipeg, in fact, is probably North America's biggest untold environmental disaster at the moment. It's a massive, massive problem. And part of it is because of some of the waters that feed into Lake Winnipeg are American in origin. It's a binational problem. So just to summarize, our natural resource sectors, whether they be agriculture or oil and gas, have decreased their water intensities in the last several decades. Right? They have done a lot of the right things. And they are forecasted to do so in the future. So we will see rates of growth, fairly significant rates of growth of water intake increases in the next 20 years, but they're still relatively small. And oil and gas, it's a regional problem. It's essentially northern Alberta, but for agriculture, it's spread right throughout most of southern Canada. If we want to think about how to address this problem, you know, oh, I forgot to slip in carbon. When I talked about pricing water, well, you know, let's be systems in the way that we think. Let's coordinate the pricing of water with the pricing of carbon, because there are clearly going to be synergies between the two. And at least in Canada, a big issue is the regulatory frameworks under which the firms operate. You may have heard that in Alberta, the federal government recently announced a significant effort to establish a fairly sophisticated monitoring network to look at water quality and air quality. You know, kudos to them. It's just a pity it wasn't 20 years ago when the things actually cranked up. You like baseline data, and we don't have that, and that's a significant, significant problem. And then the other big problem is agricultural non-point source pollution. It is a growing problem. It's something that is a real challenge, especially when we look at Canada's food exports to China, where demands for things like pork are rising quickly, and pork production is a significant challenge environmentally. So moving forward, clearly, we need to do more monitoring. Groundwater problems in southern Ontario are surprisingly bad because of years of intensive agriculture. We need to think of smart ways to regulate non-source pollution. We can do it badly, we can shut farms down, but we need to do it in a clever way that keeps farmers working, understands the way in which they do what they do, but at the same time provides them with the right incentives to move to alternative technologies and reduce polluting inputs. Valuation is something we haven't talked a lot about yet, and I just want to put it on the table. I have to admit, I'm not a big fan of the notion of virtual water, and it's largely because we never talk about the labor content of our exports or the capital content, and there's a simple reason for that. We know how to value capital. We know how to value a worker's hour, but we don't value water, and so we use these artificial measures of cubic meters of water and a ton of steel. If we valued water, it would just fall into line with largely it would fall into line with the other inputs. And so, I think we need to do a lot more work on how we value water, especially when it comes to these really tough questions of who's going to get the water in times of shortage. Oh, I did put carbon in. I'm good. So we need to price water appropriately. Ballpark figure for the average urban center in North America, and the good news is the pricing rules are largely the same in North America. Double the price of water, triple the price of water, you're getting towards the full cost of water, ballpark. And then obviously pricing carbon is going to get you a lot of the way too in terms of encouraging conservation and innovation. Thanks very much.
All right, we're playing musical chairs up here. I keep thinking of those lobsters. All right. So now the story is going to be coal. Right, Qingwei? Coal is king, and the king is thirsty. Are you going to stand?
Yeah.
All right.
So thank you, Jennifer. Mike just tell us the global water reliance of energy production. I want to give you a case study in China, how coal production and the usage is relying heavily on the water. I will try to cover these topics in 20 minutes. So first, this figure just show how coal is used in China. You can see almost half of coal is burned in thermal power plants for electricity. And this is coal industry history. From this, you can see during the past 2 decades, coal production in China has increased almost 6 times. And these are the major policy changes during the past 2 decades. So the overall trend is that the smaller coal producers now just disappeared because of continuously consolidation. So now there are key SOEs just dominate the production of coal in China. And the result of coal development in the past 2 decades, now China is seriously coal addicted. China is now producing half of world's coal and burn it. So the second is the United States, only 1/3 of China's production. So here is the most recent development of coal policies in China. so-called coal basis construction. So you can see there are 5 major coal production areas. Inside each circle, there is a cluster of smaller coal fields. So in the official document, this is called coal bases. Totally, there are 16 coal bases published in the 12th five-year plan of coal industry. So inside each of the coal bases, there is a coal industry chain, including coal mining, some power electricity, and coal chemicals. Coal chemicals, the major products are just coal to oil, coal to gas, coal to olefin. So moving backward, you can see the distribution of coal reserve in China is rather concentrated in the north west part. So to the left, to the east part of this red line, so there are 89% of coal reserve, and to the north, there are 94 coal reserve. So this is where the major coal base is located. Looks beautiful, but not exactly. Why? Look at the China water resource map. So this is a precipitation map. Left to this line, this is the arid and semi-arid China. So there are major desert and desertification land left to this region. This is a numerical way to show you the mismatch between coal and water. So you can see here. The insured coal reserve in North China is 85%, while the water resource is 23%. So in this region, where the major coal base is located, there are already very serious of land degradation. This is the map of China desertification. My PhD mentors team just made this map around 2000. I was one of the team members. This is the first time I just noticed the mismatch between the water and the energy production. Because at that time, when we try to identify which is the major cause for serious land degradation in this area, I just find the major coal and oil fields are just in this area. And after 10 years, there is the first paper I just see that seriously talking about the mismatch between energy production and water. So this is by Wilson Center, Jennifer's team. So this was published in 2011. So at that time, I was working for Greenpeace. So I was preparing another report. So I just drafted the outline of this report and signed a contract with a scientist how to write it. So when I first saw this one, I just surprised. So fortunately, my structure, this report structure is slightly different from Jennifer's one. So Jennifer's is more from macro level, the national level. And this one, the Greenpeace one, is just we check each coal basis. And we just check each coal industry. We divided them into coal mining, coal chemicals, and thermal power plants. So I think these are from two different reaches. but we have very similar conclusion. So this is the sum of the conclusion from the Greenpeace water scarcity statistical report. So overall, we calculated that in 2015, the total water consumption by coal basis will be around 10 billion cubic. But this calculation is rather conservative because at that time, you cannot verify each plant. If so many times I saw a plant just is constructing, but I cannot find it in the government's catalog. So we just don't calculate it in because I just want to be conservative to be in a very safe position. But though we are conservative, the result is very surprising. You can see the major coal producers, like in Mongolia, which is a coal champion now, and Shanxi is the second one, and Shanxi and Ningxia. We will face, insufficient water supply in 5 years. The reality is that now we have all used up their water quota allocated by central government. So how we just expand, how we can achieve their target in the 5-year plan, in the 5-year plan. So this is a game. There's big loophole in the government's management of water resources. So we are just playing games. So I don't think this kind of game can just last long because now many people are just noticing this. We cannot keep grabbing water from agriculture and from the environment. And after that, I see a series of similar reports from financial community. And this one from HSBC, talking about no water, no power. This is about the coal and water conflict in the power sector. And very recent update by HSBC. And CRSC report, also on, you can see the title here, Water for Coal, and the bank. Of course, there's Bloomberg BNF, also published a very similar report. I just found that even the central government issued the very ambitious coal basis development in the 12th 5-year plan. The investors, when they choose when they make their invest decisions, they tend to do their independent assessment. So the result is are all very similar. It's very dangerous just to keep invest in these regions. So I want to mention another just update of coal's impact on the environment. Air pollution now became very hot in China because of air quality in Beijing in recent years has been very bad. This was in March, I think. There were only 3 blue sky days during the 2 weeks. So this is outside Beijing. So about 1,000 kilometers north to Beijing. Things are even worse. About 1,200 kilometers west to Beijing, even worse. So I hate the fact only when air quality in Beijing just tend to be bad, people are just crying. Because this kind of phenomenon has been there for decades. For example, Lanzhou, I have been there for over 10 years. When I was there, no one just complained the air pollution. In fact, it is now the worst, air pollution city in China. Beijing is the second worst. So, fortunately, I just moved from the worst to the second worst. But for this reason, I hate the fact. When I came to Beijing, I find people are crying, and this is working. The central government is calling for a solution for it. But when in Lanzhou, nothing happened. Okay, so this is a numerical analysis of how coal just contributed to air pollution. So in Beijing, the figure is around 40%, and nationwide, coal contributes major part of harmful pollutants. And another big environment impact with China coal is CO2 emission. So there are around how many power plants do you know in China?
They're not all published, so I don't know. What's the guess in the audience?
Hundreds or thousands?
Thousands.
Yeah, 3,000. You're right. There are over 3,000 power plants in China. So the CO2 emission from these power plants just exceed the overall USA nationwide emission. So there are three major bottlenecks for the coal-based development recently: water resources, air pollution, and the carbon emission. So in 2008, Greenpeace East Asia just published another report just to calculate the economy loss. This loss caused by coal burning is around 7 to 9% of annual GDP of China. So these are the very recent policy dynamics, how the coal will develop in the future, how they will react to this trend. So this gentleman is a newly appointed head of National Energy Bureau. And this is their recent remark on the future of coal during, I think, last week. The promise of coal production and consumption revolution, and they want to accelerate coal-based development, and they want to shift the coal to promote the shift of coal resources from type of the fuel to raw material. Essentially, this is the coal chemical. It seems that they don't recommend any of the environment impact. We have no intention just to resolve it. Why? There's information gap. I remember when Jennifer first published the choke point China choke point report. She just mentioned that when she talked to the officials in the Ministry of Water Resources, they are surprised. They have no information. It's a shame. Even when we published our report after a year, so I talked to the officials in the Ministry of Water Resources. They are not aware of the problem. So they have no assessment. It's a shame that two NGOs just published this for the country. And information gap is a major problem. So this kind of ideas is not in their head and is not incorporated in the decision-making system. And another major reason is that coal industry is losing money in China now. From our side, we all think, okay, coal industry is enjoying its position in China, but on the contrary, they are not. Very recent, I talked to some personal friend during dinner lunch. Some are from the China National Coal Association. Some are just the bosses of the big coal SOEs. They are complaining that they are losing money and they have no bad expectation for the following 5 years. So we want a new direction to stop losing money. So we went to Beijing to ask the coal association. So the answer to them is coal chemical. So this is why the recent policy just tend to this direction. But even it looks that they are determined, but I think they will meet with the natural limit, the water resource limit. And will the future be better? The premier just recently responded to Beijing's air pollution. He just will to change the situation, but he also warned it's a long process.
I want that cap.
Yeah. So, responding to this, someone just suggests there should be a coal cap in China to reducing coal consumption in China. In fact, there are now already several caps like this. These are just incorporated into the 12 5-year plan, but not legally binding. And these are major response to the international climate negotiation. I think anyway, this target will be reached because of the statistical system of the government. But I seriously doubt the effect because I didn't see much enforcement in the really actions. Anyway, this kind of cap shows a certain determination of the central government to change the situation. But I think it's still very low, considering the new coal policies. It is still going to the wrong direction. And let's go back to the coal cap question. Will there be a coal cap? No, I don't think in the next fifth 5-year plan there will be a coal cap. If there's a cap, there may be an energy cap, because the central government just considering energy in the basket. There's no motivation just single out coal. That will hurt coal industry. They have no such motivation. But we want to single out coal because coal is the single biggest CO2 emitter. I think that's the best scenario. Or there may be an energy cap. And this is a very minor policy change, but I think it's important, so I just single it out here. We all know there is a state grid, which is monopolizing the electricity system in China. So the state grid just is in favor of thermal power plant because we can make deals with the single big one, just keep their position of the controlling the market. And a recent change is that there's a central government order. State grid should, we must buy the distributed solar PV from household So this Greenpeace, we just run a small one immediately after, I think the second day when this policy is published, we decided to do this. And now it is produced in about 22 kilowatt hours of electricity per day. It's minor, but let's think about if every household is doing this, and if the central government provide subsidy, there will be a breakthrough of distributed solar PV. So the position of State Grid will be unstable, and I think at that time the thermal power plant, they will cry because they losing their controlling position. So at least the single household, they don't rely on them. Okay. Finally, I want to go to the coal part. From 2009, China became a net coal importer, and it's increasing very fast. So about 3 years ago, there's no more than 5% of coal import. Now, it's much bigger. I'm sorry.
Oh, you're fine. You're
This
fine.
should be 2012.
Okay.
The coal import was 290 million tons. And in the first quarter of this year, it just has a historic record. It's about 80 million tons for the first quarter. So these are where the coal import comes from. So USA is here, Canada follows. So now USA and Canada want to increase its share much. And I think, just looking at the first quarter's figure, we should be happy because it's a historical high. But I think it is misleading. Why? Let us think about the motivation of coal import. It's only because of coal price advantage of imported coal. China, the problem with China coal is that the transportation to the coastal area is too costly. Transportation fee just accounts more than half of the total price. But looking at the central government's plan, we have the most ambitious plan to construct coal railway from western to coastal area. There is a coal railway from Inner Mongolia to Jiangxi, which is southern provinces. There is a coal railway from Xinjiang to east part, and these coal railways will be connected to the existing railway network. So this will relieve the transportation bottleneck. So one day, I think when this facility just accomplished, the price advantage of import coal will just disappear. And another very recent dynamic is that the thermal power plant, the thermal power companies, they are encouraged to control coal, buy coal minings now by themselves, not like before, they just rely on a contract with the coal. So this will guarantee their low price coal by themselves. So if their coal production capacity just accomplished in the recent 5 years, coal price for them will be lower. So coal import, the price advantage of coal import will disappear. So I think for long term, it's not that good for the coal traders now. And yeah, finally, some conclusions. I think I expect more and more research on the coal water nexus and air pollution by financial sectors, by NGOs, and also by government agencies. And this kind of research will promote major coal policy adjustment in the next 5-year plan. So we will see it. So Greenpeace is working for it. I know there are other organizations working for it. And yeah, coal cap. For the next 5-year plan, there may be end cap, but no coal cap. Some of colleagues just inside our team just ordered the coal cap. We said we will vary it until there's a coal cap, real coal cap. But I wanted to order this. Okay, so thank you.
Okay.
That's all.
Thank you. Maybe hand me that mic. So we're going to play musical chairs. I should let you, as we're settling down here, that in August, actually, I'm taking 4 U.S. folks, one of Mike's colleagues and a few others, going to go to China. We're forming the China Water Energy Team, known as China Wet. And I want us to all have those hats, so he and I will have to talk. All right, Q&A time. I have a mic for one of my interns to come grab. Tyler, and when you guys ask the questions, because we're on webcast, and I know you cannot yell that loud, please speak into the mic and tell us your name, and let's have succinct questions if we could.
Yes, Marcia Johnston. Question for Mr. Hightower and probably Mr. Benzetti as well. First, Mr. Hightower, did you say that agriculture for biofuels was 1,000 times more water? I mean, used 1,000 times more water, and why specifically agriculture for biofuels and not just agriculture in general? That's one question. Secondly, I'm curious as to the experience in Canada where they've reduced so well water use in both agriculture and oil and gas. Is the same true in the United States or not? And if not, if so, why?
Okay, real quickly on the biofuels. What I mentioned on the biofuels was if you use non-irrigated biofuels, if you use rain-fed biofuels, the processing of the biofuels is about 4 times what it is. If you go to irrigated agriculture, and that's where the numbers get to be very large, where you say you want to grow corn for biofuels in Texas, where you have to irrigate the corn and then do the processing, then those numbers get to be the 1,000. So I think the actual number that you want to compare is for traditional biofuels crops, it's 4 times more water use intensive than oil and gas. If you start to expand that to other regions where you have to do irrigation, that could have a large impact. And you asked a question about the water conservation in Canada. I took a tour for the Department of Energy last year on the oil sands, and the Canadians have done an extremely good job of recycling a lot of their water and changing their process for the oil sands from a lot of the open pits to a thing called SAGD, steam-assisted gravity drainage, where they recycle all that water. They've also gone to areas where they're using brackish water for a lot of the work in the oil sands, which is not competing against freshwater use. So I think those are very good approaches. They've taken a really big look at that since about 2008 in Alberta with some of the directions that the provincial government and environmental groups in Alberta have done. We're seeing exactly the same kinds of things in the United States with fracking, and there are some people here that probably know this. In 3 or 4 years ago, all the fracking companies wanted to use fresh water. They thought that they could not use high TDS water, water that has a lot of salts, and they're reusing frack water. They're treating frack water. They're utilizing lower quality frack water. So I think that all of the organizations, oil and gas organizations, are seeing water as a bigger issue, from both an environmental standpoint, water quality and quantity, and the industry itself have all started recycling, reusing, reworking the water because it is becoming a major cost driver. And in some cases in eastern United States, they can't dispose of that, so they're not going to put it back in the stream. They have to take it to Ohio to inject, so they're trying to use that water as much as they can. It's a cost benefit to them. I think that the Canadians are probably 5 or 6 years ahead, but they're picking it up. So that'll.
Stephen, you got some additions there?
Yeah, just very briefly, not so much oil and gas. I think Mike's had an excellent answer, but on the agricultural front and also in manufacturing, we've seen decreases in water intensity right across North America. And it's a complicated thing. There's effects of trade composition, so we're importing water rather than manufacturing steel in North America. There's sectoral changes within. There are changes in the efficiencies within plants. It's a whole bunch of things going on simultaneously, and it's kind of hard to figure out what's driving individual ones. Recycling sometimes buys you savings on the discharge end, sometimes on the intake end, so you have to drill down a bit. Actually, I just published a paper about a year and a half ago, breaks down what's driven the intensity numbers by sector in Canada, at least. I could give you a copy of that.
Okay, good.
So did we answer your question? I mean, did you get the answers you were looking for?
Okay. And Peggy.
So my question
Oh,
is
and
for
introduce yourself. I mean, I know
Peggy
you,
Duxbury with Bloomberg Philanthropies. And my question's for Ching Wei. I think you said, but I wasn't clear, that the carbon emissions from the coal burned in China equals the CO2 in the United States now.
More, even more.
It surpasses it. Okay, I wasn't aware of that. I knew that China had surpassed the U.S. overall, but specifically coal versus the total U.S. emissions are higher. Okay, thanks. Great presentation.
Yes.
Thank you.
Actually, I want to ask you one thing, Chingwei, that you were telling me that, and come close to the mic if you could, that you had said that the push for coal to chemicals, that's not a push coming from the top down, but it's from the provinces themselves that are developing coal. And can you tell us why they want the coal to chemicals as opposed to coal for power? And speak of the mic.
Yeah, you're right. So there are major 3 industry groups in the coal industry. One is central government. Their core interest is to guarantee enough energy supply for the economy development. So they support coal development mainly for electricity. They don't care where the coal comes from. And there's the second interest group is the coal industry itself. They just want unlimited coal and more money flow. And the third interest group is the local government. So their position is kind of complex. They welcome coal mining, but on the other hand, they don't want to repeat the story of Shanxi. Shanxi was a coal champion before 2009. And the best story with them is that they mainly supply raw coal to rest of China. Most of the coal just are transported to the power plant in the coastal area, just left damaged land to Shanxi and very polluted air. And they lose their sustainable development base. Now, the newly developed coal producers like Inner Mongolia, Ningxia, and Xinjiang, they want a totally new mode of coal development. We want a longer coal industry chain. That means we want coal mining, some power plant, and coal chemical in their land, and they want to sell out electricity and the coal chemicals. So that will encourage local industry boom. So it's reasonable, but the problem is that they have no enough water to supply to support this kind of coal industry. The complete coal industry chain is even water intensive than the purely coal mining. So it happens that in Mongolia, Xinjiang, and Ningxia and Gansu are the most arid regions in China. So That's it.
Yeah, I just wanted to get some of that complexity. Okay, over here. And then over here.
Thank you. My name is Jim Slutz, and I have a question probably for Mike, but others, please feel free to answer as well. And Mike, I'm going to ask you a combustion question. I've been in presentations where, and this is more from a systems approach of using natural gas, that if you look at, one of the byproducts of natural gas combustion is water. And I've heard it presented that if you really look at it again, recognizing that it's not necessarily in the same watershed, but if you look at the full life cycle of natural gas production and use, it's a net water generator. So appreciate your thoughts or comments on that.
Yeah, all the fossil fuels have hydrogen and oxygen bonds that actually you do create water. And you can get some pretty high values per tons of water per ton of coal, tons of water per tons of natural gas. The issue that we always deal with, and even power plants, if you do the water for cooling and you get this evaporation that comes off the cooling towers, it always ends up going to a different watershed. So what we're looking at when we do these calculations is water consumption in the watershed. So oftentimes that water that you're developing or evaporating ends up showing up in somebody else's watershed, and it detracts from your water balance in your watershed. And so, as a lot of people say, water's always local, and so we haven't really looked in detail that what the water balance is from combustion of technologies, just because it might give a misleading idea of exactly where that water is going to end up. A lot of it's 75% of the Earth is oceans, and so 75% of that's probably going to end up coming back in rainfall and in the. So it's not going to help your watershed. So, the state of New Mexico really doesn't want to look at that water because it goes over to Texas or Oklahoma, but that doesn't help them out in their local water supply. So almost everyone is looking at, when we look at water availability, it's the watershed issues that we're looking at. That's the answer. I don't know if that answers your question in the way that you wanted to look at it, but maybe Canada. Or have some.
Well,
The
I guess,
economist, yeah.
in terms of
Yeah.
thinking about alternative sources of water, ultimately desal is going to define, the lowest, whether we ever go with any alternative, it's desal and then shipping. And so there are lots of cheaper sources of water, though. The average municipal, I don't know, but I'm sure the Americans are much more clever than us on this, but in Canada, the average municipal water utility loses 10-15% of its water, and that's an awfully cheap source of new water if you really want to just start plugging some leaks. Agriculture, once again, there are still some relatively low-value uses of water in North America, and so this is why, for example, every 5 years or so, someone raises the issue of Canada exporting water to the United States, and we just say, well, I hate to think of building that pipe and then some clever farmer in New Mexico saying, I got all the water you want. It just, you look for the cheapest sources first.
Okay. This corner, can you two ask your questions one after another?
No, you go.
Oh,
Okay, mine,
Helen Raphael, RFF.
yes, Resources for the Future. It must be a great temptation for China. I have two questions about China, but the first one is about the Himalayan Tibetan water that is flowing southward to India and Southeast Asia and so forth, to divert it eastward or even possibly northeastward to Xinjiang and so forth. And has that begun? Are there any plans for that? And there's been a big hullabaloo about that when China did march into Tibet, and I'm wondering whether they're following up on the water diversion. My second question is probably very naive, because southern Russia up north of China is probably just as much desert as northern China. But is there any possibility of water being diverted back from Russia or being sold from Russia to China?
Maybe we'll answer those real quick. Do you want me to answer the Nantrui Beidiao? Yeah, in our Choke Point China reporting, we interviewed the chief engineer of the South North Water Transfer Project and asked him about the Western Line. They're moving this water south to north, and infrastructure. You guys love it in China, but the Western Line seemed even a little bit crazy, extreme, blasting through mountains. And he told us, he said, we have to do it because we have to get that water to Xinjiang, which you saw from his slide. Not only has a lot of coal, it's got a lot of high quality coal, and that's why in our Choke Point reporting, a picture of a worker inside the South North Water Transfer Tunnel is one of our key photos, because moving water to serve coal, that was a big part of our macro story, and that and which makes me think, when you have these local, if you look in a lot of Chinese provinces now and cities, desal is big on their agenda along the coast. And they're thinking of supplying it to their cities, which in essence could free water up. I mean, we've got shale gas pipelines all over this country. The Chinese are moving water, which is also very energy intensive. And then your second question about whether or not water transfers from, well, I mean, actually China, on his little chart, I mean, China's importing coal from Mongolia, and that but it's the same watershed as northern China. So I don't think that my guess that the Russians would not take too kindly of moving the water to the Chinese. It's my guess, but that's a good Choke Point Russia question for us to explore. Okay.
Jim Sang, this follows up on the first question, is for, I guess, Steve and Mike, both of them. Mike pointed out that if Canada put a nominal fee on water, they could reduce the usage with small impact on GDP. Overall, if, for example, you had this small fee, to what extent would it make it more practical to use, for example, and this was for Mike, to make it more practical to use gray water and other kinds of water? You said fracking, the recycling the water, and there are a lot of other applications, obviously, in agriculture and stuff like that, where they could recycle. At what point does that make a significant impact? What kind of price point would it take to make a significant impact on water shortages in the United States, for example? Better use of gray water and like.
Let's see. I'm not sure that I can give you a price, but I can tell you that what we're seeing is once you get to about 75% allocation of a resource, recycling reuse becomes more and more tenable, because the next increment of water that you need, you have to oftentimes go outside your basin to get. And so, as an example, whether it's a municipality or a mining, if you're really limited in your current resources, you may have to go 100 miles or 75 miles, 100 kilometers to get your additional freshwater resources. When you put that into a cost equation, it's cheaper to recycle your water, to use wastewater, to find a gray water for your power plant or for your mine or for those things. So it's really a resource issue, and once you start getting up closer to that 75%, 80% allocation, there's not that much additional water, it becomes much more cost effective for you to do recycling. I think the issue in Alberta, as an example, and I hate to speak for the Canadians since we have one here, but when you see in Alberta the Athabascan River in the north, in the summertime getting down to 25% of its general flow, that resource is getting very critical in the summertime, and that's why you've seen some of the oil sand organizations say, we can't handle that, we're going to have to look at other resources. That's why they've gone to the recycling. That's why they've gone to the use of brackish water. So it's the cost difference between that next instrument of fresh water versus what you have locally. Does that make any sense to you?
Okay. Oh, you gotta have the mic, or you can't hear you in Webland.
I guess the follow-up is, as you pointed out, the oil sand people basically recalibrated their process so they could use brackish water. Is it generally the case that there are many people who, by small tweaks on their processes, could use brackish water, or is
Absolutely. I mean, there's a number of power plants in the United States that use gray water today. It's feasible. It's doable. They're the largest nuclear power plant in the United States, Palo Verde in Arizona, uses 100% recycled wastewater from the city of Phoenix. It's doable for almost all systems. Okay.
And you must have done well because the economist was nodding as you were talking, Mike.
Well, I almost said marginal cost so that he'd really get excited, but I.
And
but
the
I
parrot
thought that,
goes, price, price, price.
But,
Some other questions? I have a hand right there. And you're next to the mic, conveniently located.
but he didn't get the chance to answer.
You got the economics right.
Okay, good. Yes, sir.
Hi, Jim Kohler. Question about the once through, I guess the definition of consumption that the Canadians had. You had the once through coal plants being a huge consumer of water. Do we define consumption that same way in the U.S.? Because it seems like, yeah, or maybe should it be defined that way? Because if you take that out, then your whole analysis of maybe trends might change. Thank you.
I'll just give you what I've found in dealing with the Canadians. No, this is, and it's not, it's all good. I like Canadians. They're really nice people, except for the economists. No. In Canada, they use the term water use, and oftentimes they don't differentiate between withdrawal and consumption. And I found that in a lot of their papers and a lot of their government papers on. So in the United States, we've tried to differentiate between withdrawal and consumption because it is important. If you have a power plant that does once through cooling where the water comes in, goes through the power plant, and goes back out, it really doesn't consume a significant amount of water. The water comes up back into the water body a little bit higher in temperature, 15 degrees higher in temperature. And so with that higher temperature, you get a little more evaporation, but it's a much different water consumption value than if you use evaporative cooling, what we call closed loop cooling, where you bring in cooling water, you evaporate it, and it evaporates into the atmosphere. So I think one of the things that we're seeing across the globe is water is not talked about. Water use, water withdrawal, water consumption, they're used interchangeably, and they're actually not interchangeable. You have to look at that very closely. And so what I focused on in my presentation was the water consumption numbers, because that's the value that actually is taken out of the watershed. And I've got some numbers from Canada real quickly that says that their water use for energy is 65% of their total. And part of that is because they use a lot of hydropower. And so if you can count water that goes through a hydroturbine as water use, it looks like a big number. Is it a water consumer? No, it comes through, goes through. So I think locally and collectively, we're going to need to start looking at this term consumption and withdrawal because they give different meanings. I think the term consumption is the right value to use, and that's what we should focus on, but that's not what we all do.
If I could just follow up very briefly, I agree completely. Just a plug to the good folks at Statistics Canada, for the last 30-odd years, we've been having these quinennial, every 5 years, surveys of industrial water use. And as far as I know, we're the only country in the world that has done that. So that these are plant-level observations on water use. And it's given us a very, very rich database that allows us to drill down literally to, now oil and gas was different, but other than that, and the geographic, the folks who do water collection water day in the States, they don't have the same level of data. They impute it with coefficients. And so, and it was really brought out by your talk that, before you get to policy, you have to have numbers, and you hope, and then some good engineering and economics on top of the numbers. But, first you got to have just the numbers. And to their credit, the Canadians have actually gone that route, and it's going to become critically important as we go, as Mike's data showed in terms, or the presentation, the future and climate challenges. And so you have to invest in the number gathering first.
I will mention, just to show that I like Canadians,
What about the Chinese?
Yeah, I like them
haven't
too.
Praised the
Okay.
Chinese at all up there.
But the last time we did water consumption census in the United States was in 1995. We do water withdrawal data every 5 years. We haven't done water consumption evaluations since 1995. And that's a long time. That's 20 years without understanding what the real water consumption values are. Now have been some legislation from Congress to actually provide funding for a new water consumption survey. The USGS is doing that. We'll see how that's going, but it is difficult to try and balance a checkbook when you don't know what's in the checkbook. Yeah.
But I should highlight too, and we'll have to have you back, Mike, because Mike's also involved working with the DOE and the National Science Foundation. They're different, but on this kind of road mapping for research for the water energy nexus issues, and getting the DOE to think about water. I think that's thumbs up. But the last thing about the consumption use issue, but even in some areas, but even if you don't consume the water, when you do have droughts, like we saw, you still, if it's not there for you to use, that's still a problem.
Water withdrawal is an issue, if you don't have the water to withdraw.
Good. All right.
And so these drought issues, like you see in the Southeast United States,
Okay.
a lot of those plants are not consumptive use, but they didn't have the water to even use for once-through cooling.
Okay, we got a desperate follow-up
Yeah,
here in the
just
middle
a
of the
quick
room.
follow-up, just to make sure that all the water use surveys then in Canada are consumption, right? This is not, no, this is so, to his point
the data
earlier.
differentiates between intake, recirculation, consumption, discharge, all those good things.
perfect thing.
So they're awesome up in Canada. All right, in the very back of the room, always hesitant, usually a troublemaker there, but all right. And if you could stand up so we could see you and say who you are, please.
I am Todd Thurwachter with the U.S.-China Foundation for Exchange and Development.
Thank
I appreciate that this has been specific to coal, but I was just curious as far as the extraction of tar sand oil and the transportation of it, how that would compare to coal in terms of water usage.
I can't speak to China, but certainly I dread doing any kind of engineering analysis here, but my understanding is coal mining uses relatively little water. Most mines, in fact, produce water, and that's the problem. Oil sands, if they're surface facilities, they don't use much more water than a standard mining operation. Where the water use really spikes is in the in situ use for steam, and that's very high. But as Mike correctly pointed out, a lot of that now, at least up in northern Alberta, is reclaimed. It's either reclaimed or it's saline groundwater that's being pumped, used, and put back into the ground. I don't know whether there's any tight.
No tight. Well, there's tight shale discovered in China, but that's still new. But I have a question for you. In Greenpeace, you've done the Thirsty Coal report, which I was very excited about, because you proved that we said was kind of going in the right direction. So it's always nice, affirmation. But what's next for Greenpeace China? Coal, you're wearing your caps, but in terms of the water-coal nexus confrontation area, what are you planning, or is it a secret?
Okay, so first I want to go back to the question of water consumption. So I think water intake can be a serious problem. For example, when we had field trip, we just found coal plants, the pumping groundwater from a certain area. So in 3 years, water level just decreased over 100 meters. So there are around 2,000 wells made by the family there, just abandoned because of the typical depth will be around 30 meters. So they must turn to new water resources. So this water displacement. So this kind of water may not be consumed, but you just remove it from that circumstance. It hurt the environment. It hurt the local communities. So I think this is our next step. So we are going to check every coal basis how water is taken from the environment, how this just impact the environment and impact the local communities. So I think there are around 16 coal bases. It's not that much. We'll check that, and we will have very detailed report on it. And I think in the following years, you will see more and more detailed data on cases. And we also want to find a solution, cooperating with other organizations, even with, central government departments. So are there any solutions? Should we stop coal basis, or we should we should adjust the coal basis plan accordingly to the coal to the water supply? Yeah.
But one thing I was also struck with, when I saw an interview from one of your colleagues that flagged for me that the 12th five-year plan for energy development had one line in there that brought up coal's water footprint. And there were no targets, but it was, I mean, I get excited about these things, but it was really striking that they actually mention the water-coal nexus. So do you think that a door is opening for engagement with the government on this topic?
Yeah. So I'm excited at that.
Okay, he's excited too.
Why? Before you and me talk about these issues, I cannot find other information. Now, finally, the recent government documents, like the plan you just mentioned, and another plan which is Yellow River, management. It is about overhaul of water resources in Yellow River Basin. Almost every newly published document just mentioned the coal and water nexus. They want to address this. I think you and me and other groups are key, the key factor just to input this kind of information into the government departments. When I talk to them, they are surprised. But later, I found, someone just came to us, just asked, do you have detailed information? And some even just asked, can you just write a special report for us? And
for free, right?
yeah, it's free. And there are also coal power plants, coal power companies just come to our office to ask for reports, more copies of the reports. So I'm excited at the development of the issue. But, there's a long way to go ahead from the idea to the really action to address the problem. There should be a major policy change.
I think that, but again, with just, the Wilson Center working with Circle Blue and others, we're creating this China Water Energy Team, which the first one, there's 8 people because that's a lucky number. But it's not going to be, we want to continue doing this because the China Environment Forum, we're an information clearinghouse, and that's why we dragged him out from New Mexico. Now I realize I need to have a water economist on these kind of things. But we're going to be doing this more, so I hope you guys don't mind that, with you as well, that we're going to be bringing more of these kinds of conversations, trying to move from the describing the problem, but looking at, because Mike, you guys at Sandia, aren't you working with the Great Lake Basin on doing an assessment? And I assume that's working with the Canadians too, because they're part of the basin. And that's a kind of, for me, that strikes me as an interesting model because that's at a massive scale, looking at the water energy confrontation that could be comparable for China. Will it be useful to?
Absolutely. We're doing that for the whole Western United States, for the Western Governors Association, for energy production and development in the West. Where the water resources that could support power plants? Where are we going to need to use brackish water or wastewater? So we've done that in the Western U.S. with ERCOT, which is the Texas grid. We worked with the Great Lakes Commission to look at that. And so there are some models that can help you look at these interdependencies and your water balance for all of your needs, domestic agriculture, and begin to figure out how do you trade that off from an economic standpoint and from a sustainability standpoint. Where are there places that really does make sense to rather withdraw water from the Great Lakes to cool power plants such you're not, and put it back in there such that you're not consuming? And you have to play that off and look at where the best places are. And so we're doing the same thing, like I say, in the 17 western states for the Western Governors Association. Hopefully it will allow people to look at these interdependencies and do planning a little bit better, which is what we need to do. We need to get everybody in the room and be able to plan at these high levels a little bit more appropriately, or we're going to end up without the water resources to meet that development.
And maybe someday we'll get you to northern China. Final word from the.
Very briefly, you know, along that line, the International Joint Commission, which is
Oh, yeah, yeah.
responsible for governing transboundary waters between Canada and the United States, in the last decade has done 2 very large studies, one for the lower lake system in the Great Lakes, one for the upper. And, you know, they've done some fairly sophisticated climate modeling, but also more importantly, what we call hydroeconomy models, where you try to link economics and water, the hydraulics, and you can use that as a tool. You get all the relevant stakeholders in a room and you say, you know, if we give more water to commercial shipping, what's it going to do to soil erosion, et cetera, et cetera. And it's a very useful management tool. It's a very useful educational tool. You can resolve disputes with it. And I think that working model is a very valuable one that I don't think the IJC gets the press it deserves.
I actually took a commissioner from IJC to China with my water conflict resolution tour a number of years ago. So no, thanks for flagging that again. Any last word?
Well,
Wear
I
your
think
caps.
I think my colleagues will wear in the coal cap for a while, but I think if the order the energy cap, that will be a short time. Last word, I want to address the coal import to China, because many people have, especially in this part of the world, have big expectation of coal trade. I personally think in the long run it will be very risky, because you know China coal power plants just use coal import as a tool to bargain with big SOEs, because you know China is the biggest coal producer. It cannot find equivalent coal outside China, so we just use it as a tool. A tool cannot be the major part. So don't expect it can be that big, the market. And especially in the target area, target market in the coastal area, the electricity capacity has stopped increasing for several years. Is official position. Just no new coal power capacity should be built in this region. And with the relief of transportation bottleneck, the coal price advantage of imported coal will disappear. So the future is not that good.
You know, you got those Montana and Wyoming and West Virginia coal people crying this morning here. All right. Could I ask you guys to applaud one more time for all 3 of these speakers? And also we should take our coal hats off and thank, the people who help us make this happen. For me, the Skoll Global Threats Fund, Energy Foundation, Rockefeller Brother Fund, Vermont Law School, USAID, and Blue Moon Fund are all, see, we've converted these guys into water energy folks too. But thank you all for coming, and they're here for a bit. You could gently tackle them. Thank you. Good job. Excellent. That was great.
Hello, Mark. How are you?
But it's just that it's better, 'cause I knew what to ask. So, but why don't you talk?